There is a question that quietly haunts modern engineering. A question very few people inside the automotive industry are willing to ask out loud. Are we truly innovating, or are we simply making things more complicated? For more than a century, the Western automotive industry, led by the giants of Detroit and the precision engineers of Germany, convinced us of one simple idea: more is better. If 4 gears are good, 6 must be better. If 6 is standard, 8 must be luxury. And then, in a moment of mechanical excess, the industry pushed even further. 9 gears, 10 gears. Companies like Ford Motor Company and General Motors joined forces to create incredibly complex 10-speed transmissions. Even brands like Mercedes-Benz chased the same dream. They presented this to the public as the peak of automotive refinement. But standing here in 2026, looking back at the last decade, it becomes clear that something else was happening. This wasn't innovation. It was a desperate attempt to save a dying system. While Western automakers were building ever more complicated gearboxes, something very different was happening in China. Quietly, methodically, Chinese engineers looked at the modern 10-speed transmission and reached a surprising conclusion. It was unnecessary. Instead of trying to improve the gearbox, they simply removed it. To understand why this happened, we first need to understand the tragic flaw of the internal combustion engine. The piston engine, whether petrol or diesel, has a very difficult personality. It cannot operate when stopped. It must maintain an idle speed. If it spins too fast, it risks catastrophic failure. And most importantly, it only operates efficiently within a very narrow window of engine speed. For most engines, that sweet spot sits between 2,000 and 3,000 RPM. The entire history of automotive transmissions is essentially a story of engineers trying to keep the engine inside that narrow window. In the 1970s, cars typically had 3 or 4 gears. On highways, the engine screamed. On hills, it struggled. By the 1990s, 5-speed transmissions became common. Then came the 2010s. Environmental regulations in Europe and North America tightened dramatically. Automakers needed every possible improvement in fuel efficiency. Their solution was simple: add more gears. By slicing power delivery into smaller steps, the engine could theoretically stay closer to its optimal RPM. This is how transmissions like the ZF9HP and the 10R80 were born. On paper, the idea was brilliant. With 10 gears available, the engine could always run at the perfect RPM regardless of vehicle speed. But in the real world, things became far more complicated. Inside a modern 10-speed automatic transmission is a mechanical labyrinth. Multiple planetary gear sets, 6 clutch packs, a hydraulic valve body filled with dozens of oil channels. Fluid pressure must move through these tiny passages at exactly the right moment to activate solenoids that control gear selection. If just one solenoid fails, a component smaller than your thumb, the entire transmission can stop functioning. And then there is the driving experience. Many drivers of vehicles like the Ford Ranger or Mustang equipped with 10-speed gearboxes have noticed something strange. The car constantly searches for the correct gear. Driving at 50 miles per hour, you press the accelerator slightly. The transmission hesitates. Should it shift to 7th gear or 6th? Maybe 8th? The system changes its mind again and again. This phenomenon is known as gear hunting. Instead of delivering smooth acceleration, the transmission spends valuable time deciding which gear it should be in. This delay creates a disconnect between driver input and vehicle response. China's engineers saw this complexity very differently. To them, every additional gear meant more friction, more moving parts, more energy lost inside the transmission. Fuel was being burned just to spin the gearbox itself. So, companies like BYD and Great Wall Motors approached the problem from a completely different angle. They asked a simpler question: what is the most efficient way to deliver torque to the road? Their answer was the dedicated hybrid transmission, or DHT. The revolutionary aspect of this system is not what it adds, it's what it removes. No torque converter, no multi-gear transmission. At lower speeds, typically below about 50 miles per hour, the internal combustion engine is completely disconnected from the wheels. Instead, the engine functions purely as a generator. It spins a generator that produces electricity. That electricity flows to a battery and then powers an electric motor. And it is the electric motor that turns the wheels. This is powerful because electric motors behave very differently from combustion engines. They produce maximum torque instantly at 0 RPM. They do not need first gear to move a vehicle. They do not need multiple gears to build momentum. Power delivery is smooth and continuous. Mechanical complexity is replaced by electrical simplicity. Instead of gears and clutches, energy flows through wires. And this is where Chinese engineers made their most important decision. Because the internal combustion engine is no longer responsible for directly powering the wheels in city driving, it can be optimized for just one job: generating electricity efficiently. Many of these engines use a variation of the Miller Combustion Cycle. In this design, the intake valve stays open longer during compression, pushing some air back out of the cylinder. In a traditional vehicle, this would reduce power, but for a generator engine, it dramatically improves efficiency. The engine runs steadily in its most efficient operating range, while the electric motor provides instant torque to the wheels. The result is a driving experience that feels smooth, powerful, and remarkably efficient. Skeptics often argue that hybrid systems struggle at highway speeds, and years ago that criticism was fair. But modern systems solve this problem through something called direct drive mode. At steady highway speeds, typically around 60 to 70 miles per hour, a single clutch connects the engine directly to the wheels. But instead of shifting through many gears, it uses a single long ratio. At this speed, the engine is finally operating in its natural comfort zone. No complicated gearbox is required. And if additional power is needed, the electric motor instantly provides extra acceleration. The system blends both technologies seamlessly: electric power in the city, direct mechanical efficiency on the highway, without the complexity of 10 gears. For fleet operators and logistics companies, this design offers another critical advantage: reliability. A modern 10-speed automatic transmission contains hundreds of components that can wear or fail. Fluid degradation, clutch wear, and valve block contamination can eventually lead to expensive repairs. When these transmissions fail, they are rarely repaired, they are replaced, and the cost can rival that of a small used car. In comparison, a DHT system has far fewer mechanical wear components. Electric motors rely primarily on magnetic fields rather than physical friction. Fewer moving parts means fewer failure points, lower maintenance costs, lower downtime. For commercial vehicles and pickup trucks, this difference matters enormously. In many ways, we are witnessing the end of what might be called the mechanical Baroque era of engineering. The Baroque period in art was famous for excessive ornamentation and elaborate complexity. 10-speed transmissions were the automotive equivalent, technically impressive but unnecessarily complicated. Modern hybrid systems embrace a different philosophy: functional minimalism, doing more with less. Today, the important question is no longer how many gears does your vehicle have. Instead, the question is much simpler: does it even need them? Many Western manufacturers are now racing to simplify their systems, but years were spent perfecting gearboxes that may soon become irrelevant. Because the future of automotive engineering may not belong to the machine with the most parts. It may belong to the one that achieves the most with the fewest. And in that future, the quiet flow of electricity may finally replace the noise and vibration of mechanical gears. The gearbox did not disappear because it failed. It disappeared because it became unnecessary. Drive safe, and I'll see you in the next one.